Europa looks finished. Phobos looks like a rock that went through a war. And that difference should not exist by accident. All across the solar system, some moons are round enough to look like worlds, while others look battered, lumpy, or even absurd. So why does that happen? Why do some moons end up smooth and planet-like, while others look like cosmic leftovers? And what if those strange shapes are actually clues to how violent the solar system used to be? Chapter 1. Not all potato moons are the same. Phobos isn't the only potato in the solar system. Mars has 2 ragged little moons. Neptune has Proteus, which looks more like a jagged chunk of rock than a clean, coherent world. Saturn has Hyperion, full of deep craters, like something that survived far too many impacts. And then there are moons like Pan and Atlas, whose shapes are so bizarre that they almost stop looking like moons at all. That is where this gets interesting. These objects may look equally weird, but they are not weird for the same reason. Some are simply too small for gravity to pull them into shape. Some may be captured objects. Some were smashed, reshaped, or built up by their environment. So if we want to understand why these moons look like potatoes, or ravioli, we need to separate one kind of cosmic weirdness from another. Chapter 2. Sometimes gravity is just too weak. The first reason some moons end up with these strange shapes is simple. They are too small for gravity to smooth them out. We tend to think of gravity as the force that always wins. But on a small moon, it doesn't. Rock and ice can hold their shape instead of slowly collapsing into something round. That means dents, ridges, stretched outlines, and impact scars can stay visible for billions of years. A larger moon has enough gravity to pull itself inward from every direction and settle into a rounder shape over time. A smaller one never really gets there. In that sense, some of these potato moons do not look unfinished by accident. They look exactly the way weak gravity allows them to look. Phobos is a good example. With a longest dimension of just 27 kilometers, its average surface gravity is only about 0.35% of our moon's. Proteus shows how close that boundary can get. It is over 400 kilometers across and much closer to round than Phobos, but it still is not fully spherical. NASA describes it as irregularly shaped and heavily cratered, and planetary data models describe it more like an irregular polyhedron than a clean sphere. In other words, Proteus sits near what scientists describe as the hydrostatic equilibrium threshold, where self-gravity becomes strong enough to pull a body toward a nearly round shape, but has not fully taken over yet. But small size is only one kind of weirdness. Some moons look wrong because something happened to them. Chapter 3. Some moons keep the scars. Weak gravity can preserve a strange shape. Violence can create one. Hyperion is a good example. NASA describes it as the largest of Saturn's irregular, non-spherical moons, with dimensions of roughly 410 by 260 by 220 kilometers. A shape so uneven it sounds irregular even on paper. It looks like something that never fully recovered. Hyperion is thought to be the remnant of a larger moon destroyed by a major impact. It has a deeply cratered surface, an unusually low density, and it tumbles chaotically through space instead of rotating in the calm, predictable way we expect from most moons. That matters because our own moon is full of craters too. So impact damage alone is not enough to explain a shape like this. The difference is that the moon has enough gravity to stay broadly round, even after billions of years of impacts. Hyperion does not. On a body that small and porous, collisions do more than scar the surface. They help define the entire object. So some moons look strange because gravity never finished the job. Hyperion looks strange because the job may have been violently interrupted. Chapter 4. Some moons grow the wrong shape. In the case of moons like Pan and Atlas, the strange shape seems to come from something else entirely. Their mean diameters are only about 28 and 30 kilometers, but their true outlines are much stranger. Pan is about 33 kilometers across at the equator and about 21 kilometers from pole to pole, while Atlas reaches about 42 kilometers across and only about 18 kilometers from pole to pole. Instead of looking merely rough or damaged, they look swollen around the middle, almost like little flying saucers. That odd bulge is probably not random. Pan orbits within the Encke gap of Saturn's A ring, while Atlas circles near its outer edge. In places like that, these moons move through a constant cloud of icy debris. Over time, their weak gravity can pull in some of that fine material. But instead of spreading evenly across the surface, it is more likely to build up around the equator, where the moon's motion through the ring environment keeps feeding that region. The result may be a moon that did not just survive its surroundings, it literally wore them. So this is a different kind of weirdness again. Some moons stay misshapen because gravity is too weak. Some look broken because they were hit. But Pan and Atlas may look bizarre because Saturn's rings slowly helped sculpt them. Chapter 5. Some moons were captured. Some moons may look strange for an even deeper reason. They may not have formed around the planets they orbit today. Saturn's moon Phoebe is one of the clearest examples. It moves on a retrograde orbit, has an unusually dark surface, and NASA says it is most likely a captured object. Jupiter's moon Himalia may fit the same broader pattern. NASA describes it as the largest member of the Himalia group and suggests it may be the largest remaining fragment of an asteroid captured by Jupiter's gravity. That changes how we read a moon's shape. A captured moon does not have to begin its life as a neat, rounded satellite. It can arrive already irregular, already fractured, already carrying the scars of collisions from somewhere else. So sometimes a moon looks strange not because it formed badly where it is now, but because it may be an outsider that was trapped later. Final thoughts. In the end, some moons look strange because gravity never finished the job. Others were shaped by impacts, sculpted by their surroundings, or captured long after forming somewhere else. But together, they point to the same larger truth. A moon's shape is not just appearance. It is history, frozen into form. The smooth ones tell you gravity had enough power to take control. The lumpy, broken, and bizarre ones tell you the solar system was once far messier, more violent, and more creative than it looks today. Sometimes the fastest way to read that history is not to ask what a moon is made of. It is to look at its shape. Subscribe for more stories like this, and if you want to see one of the most extraordinary moons in the solar system, watch our video on Titan next.